For any cyber attack to succeed, multiple steps or stages are required, all of which are supposed to succeed in achieving their goals, until complete penetration is achieved, and any failure in any step leads to the failure of the entire attacking process. For this reason, the attacker may try hundreds or thousands of times before the attack succeeds, but when he succeeds, then this time is very sufficient to say that he has won. Defenders need to win every time, while attackers need to win only once. As a result of this, we, as defenders, have to harden the defenses of the network and systems, which leads to the detection of the attack or the complication of the penetration process so that it becomes exhausting, stressful and costly for the attacker. So he cancels his attack or perhaps pauses it, which gives us some time as defenders to be prepared. Defense in depth is an example of this reinforcement or hardening, which is using multiple security defenses, as if there are several fences, for example, one or more of them thwart the attack in one of each stage. As defenders, we have to understand the general framework of the attacking process, or the steps of the penetration in general, so that we can design and prepare our defenses for the purpose of stopping or detecting the attack before its completion, or in the worst case, responding properly to handle the effects of the attack and tracking the attacker. Penetration testers or ethical hackers must also understand this framework in order to perform their function of simulating attacks and detecting vulnerabilities, in order to close them and hardening network and system security. There are several frameworks or models of the penetration process, including the ones from SANS, NIST, CompTIA, and BTIS, all of which are very similar, as there is a separation or merging of some stages in one model compared to the other ones, with little difference in the designations. And there is the Lockheed Martin's cyber kill chain model, which we will be talking about today. The concept of a chain of killing is a concept used by armies to describe the structure or stage of an attack, starting with defining the target, sending the force to the target, the decision and command to attack the target, and finally destroying the target. The stages of the cyber killing chain model are as follows. Reconnaissance. Here are two steps executed one after another, which are found as two separated steps in some other models, namely information gathering and vulnerabilities identification. So first we have gathering information about the nature of the target, its business and its employees, the network structure, the types of servers used, and their operating systems. Information gathering can be passive in the sense that there is no direct contact or connection with the target, and which can be by searching using free public sources of information such as search engines like Google, for example, social networks such as Facebook, Twitter, LinkedIn, and so on, and using tools such as Whois, NSLOOKUP, FOCA, Shodan, Maltego, and the Harvester. This is called open source intelligence, and it results in getting information about the target company employees and their positions, their relationships with each other and with other people, for the purpose of using social engineering later on. Other information that can be gathered include network, IP addresses, domain names and subdomains, web page, technologies used in developing company sites such as PHP, Java, .NET, and frameworks and content management systems like Drupal, Joomla, WordPress, and others. This will be followed by active information gathering, and here we have direct communication with the target to obtain more detailed information about it, such as the internal network addresses in detail, the services available and open ports on hosts, and operating systems types and versions used on these hosts. This step is usually performed by port scanners, and the most famous one of them is Nmap and its graphical interface called ZenMap. There are other ways to obtain this information, such as making use of central management systems such as SCCM, logs of DHCP servers and routers, and ARP tables. There are also other passive methods for identifying operating systems by analyzing packet captures. The P0F tool is an example of that. Vulnerability identification. Gathering information does not mean automatically identifying vulnerabilities. Knowing that you have a window does not mean that it is open or closed, but it can be easily broken or dislocated. You should find the weak point in this window. Likewise, your knowledge of the network architecture, operating systems, or application of the target does not directly mean discovering a vulnerability. The attack success depends on the presence of certain weaknesses in some or all of these target elements, caused by non-patched software, settings misconfiguration, or a zero-day vulnerability. Some of the tools used at this phase are OpenVAS, Necto, SQLmap, Nessus, and Nexpose. Weaponization. Here we have the process of developing the appropriate tools to exploit the vulnerabilities discovered in the previous step. That window, what is the right tool to take it off? By what can we kill or numb this guard dog? This step is often done using automated malware development tools. Delivery. How do we get to this window to start taking it off? How do we deliver poison or anesthetic to the guard dog? Here we deliver the malware to the target by email or on USB, using social engineering, exploiting a specific vulnerability in the network or applications, or other means. Exploitation. Here the process of exploiting the target starts when the victim or the attacker performs some action to activate or trigger the malware. For example, the victim clicks on an email attached file which contains the malware. Installation. Here the attacker seeks to obtain permanent or persistent access to the target system, since the malware used in the previous step only lead to temporary access to this system. Examples include the creation of a backdoor in order to return to the target at another time. We enter the victim's home and copy the key. Command and control. The attacker can access the target at any time as a result of the previous step, but here in this step, he will seek to control the target in order to benefit from it. The attacker will use some method of remote access to the target and control it manually or automatically for purposes such as DDoS attack, where the victim is one of hundreds or thousands of systems used in this attack as part of what is called botnet. Actions on objectives. Here the attacker reaches his final goal of the attack, such as carrying out a distributed denial of service attack as mentioned previously, theft, modification, or deletion of sensitive information, or pivoting from the compromised systems to other systems or parts of the target network, and restarting the cycle of the cyber killing chain again.